Let's have a look at two very useful features that are available in the Medmont Studio 7 software. These are particularly useful for trying to anticipate where the treatment zone following night lens wear is going to happen, or if you're fitting a multifocal lens where if there's any decentration that might occur with the multifocal optics. So in this case, we've got a patient who is a night lens wearer, and you can see from the comparison map that the treatment zone is slightly decentered. So we're looking to line up this cross-section bar where the green crosses. So we're about between the 1.6 and the 2.4 on that side, between the 1.6 and 2.4 on this side. The middle of that bar is where the middle of the treatment zone is, and that's around about 0.8 of a millimeters decentered. So what we want to do is, can we do anything to anticipate where this treatment zone is going to be? And if we look at just the baseline map, and we obviously started with a normal cornea with no issues, no indications of any ectasia. And we're then going to use if we look at it in axial, there's two things that we're going to consider. The first of all is, in the annotations, we're going to look at the iris. So we're going to define the iris, so we can put the iris border where the grey meets the grey, and we can see that we've got an average sized iris there at 11.8 millimeters. Now, the useful attribute is this iris center X on the right hand side, and you can see that we've got 0.3 millimeters of decentration. So that means that the middle of the geometrical center of the cornea is 0.3 millimeters away from the visual axis. So that's a good indication from the point of view of a low angle kappa angle lambda. The next attribute that's useful is this defining the contact lens optic zone. Now, the way to do this is to pick a contour. I'm going to pick a contour that's the sort of pale orange on this side. I'm going to drag this over till I meet the pale orange on the other side. That's the same colored contour along the horizontal line. And you can see that we have a contact lens displacement of 0.78 millimeters. So that would mean that we would expect the treatment zone of the night lens, or if we had a multifocal soft lens, to be decentered by around about between the corneal center, which was 0.3, and the contact lens displacement, which was 0.78. And again, if we go back to looking at the comparison map, 0.8 of a millimeter, so it was close to the contact lens optic zone center. So yeah, 0.75, thereabouts. So a very useful tool as to how we can anticipate the decentration. This follows on, of course, to measuring the spherical aberration, because decentration of the treatment zone causes increased spherical aberration. So you may want to select a larger optic if you're anticipating a decentered treatment zone. You might find other videos in this series useful. If you don't know how to add the attributes on this side, there's a video on that. And there's other videos on spherical aberration with myopia management. Thanks for watching.